In this lesson, we're going to start to introduce experiments and how we compare two groups, the control group and the experimental group. So our first question we're going to look at is, does taking driver's education make people drive slower? We're going to answer the following about the above question. It seems like a simple question, but how could we definitively answer it and show that driver's education either causes or does not cause people to drive slower? So this is something to think about. In class, we'll be talking about it, and it's just a problem to solve, and it's a problem that's related to statistics. So here, after you think about that for a little while, here is the second question. Would we get valid results for the answer to the above question if we conducted a survey of people who already took driver's ed and those who did not take driver's ed and compare their fastest speeds? Why or why not? So if we think about this, we're trying to prove causation. So the answer to this is no. We need to do an experiment to prove causation. Because maybe people that sign up for driver's ed are already more conscientious and more likely to drive slower. We can't really say it's the driver's ed unless we randomly assign people to groups. So in exercise 2, we're going to look at an experiment like that. So a group of 20 17-year-olds were randomly assigned to two groups. One took driver's education and the other did not. So they were told the one group was going to take it and the one group didn't, randomly assigned. 3 months after completing the course, all participants were asked, what is the fastest speed you have driven on the thruway, speed limit 65, in the past 3 months? The results are shown in the table below. So here we have the driver's education group. This is the 10 participants and the numbers that they reported. The no driver's education group, this is the numbers they reported. So the first thing we do with an experiment is we want to find the group average. So you could do this, and I'm not going to show this in the video because we should know how to do this. We could add them up and divide by 10, or we could type them in L1, right, and get the average with one variable stats. So the average of the first group is 73. The average of the second group, if you typed that in L1 or found the average, is 83. Okay. So the next question says, if driver's education does not make a difference, what would you expect? Would you expect the means, X bars, of these two groups to be equal? Why or why not? So let's say it actually didn't make an average. Would we expect the two group means to be exactly the same? And the answer is no. We know even if people are randomly assigned, just kind of like when we did the pulling out the chips before, we don't expect everything to be exactly the same, right? Randomness does create some differences, right? So we would expect some difference, just, we'll say, by chance. So I already did this. We calculate the mean for each group in the last column and record it in the table above. Now, once we get two group means, we label these, whatever is defined as our first group is our first group mean. So this is just a subscript 1 saying first group, and that's X bar 2. To find the difference between the two means, this is question C, we always do the first mean minus the second mean. So just to have a standard way to do it, so that's 73 minus 83. Which is negative 10. This is called a difference value. So a question that we're going to be exploring is, do you think this difference could have happened by chance because of the random assignment to groups? Or can we conclude that driver's education versus no driver's education makes a significant difference in the top speed people have driven? So is negative 10 a difference that happens often by random chance? Or do you think it's a big enough difference that we can say, yeah, probably not by chance, that is a real difference? And that's the question. You can have an opinion on it. You can write something down, but that's the question we're going to be answering. So going to the next page, we're going to start to investigate how we can answer this question definitively. So we're going to see what happens when we take the 20 data values, mix them, and divide them randomly into two new groups. So I will be taking these 20 values, shaking them up, right? Kind of like in a baggie, you can imagine, and then splitting them up into two new groups of 10, two completely random groups that have nothing to do with whether or not they were in driver's ed. But to save time, we're not going to do this with an actual bag, kind of like we did with the chips. We're going to use technology and specifically a Google Sheet to do it. So the way you're going to get this is in Google Classroom. So I'm just going to change the view on this so we can fit both of them. So if you go to Google Classroom in some sort of window, and this will be much more easily done in class. We're going to do it on computers. Google Sheets is kind of hard to use on a phone. So if you go to our classroom and you go to the classwork tab and you scroll down to statistics, I have an assignment called Lesson 103 Spreadsheet. So you're going to open this document here. Now, yours will have your name on it, so you don't need to make a copy. If you make a copy like I'm making a copy, that's fine. It will still work, but it should give you your own copy of this. So here I have the driver's education numbers. Their group mean is 73. If you look here, I have a little average function because I know how to do that in Sheets. And then this is the no driver's ed, their average function, and 83. So we're adding up the cells B11 through B20. So it says in this sheet, you will see the same data. You will be randomizing it 5 times and recording the new means and difference values by doing the following. So you are going to, highlight the cells. Okay, so first I skipped a step. Go to the second tab by clicking on random groups. So we're clicking right here. So right now, they should have the original data in order. Now, I think one of the other teachers looked at this, so it's not the original data. Sorry, I'm just going to get the original data again. So I'm going to copy and paste this just so, and yours should be fine. Okay, so as long as everything's good, that's my original data, original average of 73, original average of 83. So now we're going to go through these steps, highlight the cells in column B, B1 through B20, which is what I already have. I'm going to right click, choose view more cell actions at the bottom of the options, and then I'm going to choose randomize range. Okay, so just highlighting those 20 cells. So here, I'm now going to record. So randomly, this group, the top group, had an average of 74, and the other group had an average of 83. Okay, so that's going to give me an average or difference value 74 minus 83, and I'll just write this once, is negative 9. Okay, so then I'm going to repeat this process 4 more times. So right click, view more cell actions, randomize range. Here I had 75 and 81. Subtracting them would give me a negative 6. And you should try this a couple of times yourself. Okay, 80 and 76 is positive 4 this time, right? Because 80 minus 76 is positive 4. So this time I had 81 and 76, so I had a difference of 5. $75 and 81. So 75 minus 81 is negative 6. Okay, so those are my differences that happen by chance. And you should really be able to see that chance, right? Because I'm just randomly assigning them. So what you're going to do is in class, if you were here, we would have a dot plot like this. Okay, and I would put my values on. So my first one was negative 9. My next one was negative 6. My next one was 5. My next one was, my next one was 4. Then I got 5. Then I got another negative 6. And all of your classmates, so let's say there's 20 people in the room, would go and put their 5 dots on the board. So we'd have 100 dots. And basically we're seeing like what happens with this randomization plot. So now I'm going to go to the next video.